I'm Robert Coop. I just go by Coop. I'm the Director of Machine Learning here at phData. We are a Dataiku partner. We recently did a blog post exploring how to apply some advanced deep learning within Dataiku. So that's what I'll talk about here today. I'll go through the general structure, and then most of the time will be spent in the Dataiku environment showing you how we put this thing together. We'll post in the project or in the LinkedIn Live comments some links here. The first one is going to be for our blog post that covers all of this in detail. The second link will be for our GitHub. So if you have the Dataiku environment, you can import our project from there, or just kind of browse through there and look at the actual code. So the general idea here is to use deep learning to classify emotions in videos. And I'm just realizing I've closed my actual video window, so let me show you what I'm talking about when I talk about the emotions we're looking at. So what we do here in the general project is to take videos containing actors that are speaking lines with different emotions. So I've got some extracted frames from these videos. So here is a neutral emotion. And I forget exactly what phrase the actors are saying, but it's a very unassuming phrase, something like the bird is in the birdhouse, or of similar nature, not anything terribly exciting. But they are acting out different emotions as they go through these. So let me jump down here to something more exciting. So here's angry. So you can see they are very much acting very dramatically. Actually, there's a subtle and a dramatic version of each emotion. So that's what we're starting with. So let's kind of look at the overall structure. Here's our Dataiku flow, which I'll go back to in a second. But here in the blog, I've got some graphics that kind of help explain what we do. So we take our test videos, of which I think we have about 2,000 videos, somewhere around there. It's a reasonably large number. And we extract frames from the video. We run them through a deep learning image classifier to classify each frame as an emotion. And then we take a majority vote to get the video itself. So I'll now just kind of step through the Dataiku environment and how we have that set up. I'm going to not go through the process of installing the deep learning for image classification plugin. That's covered in the blog and on Dataiku's site if you need more information. We have two different sort of signal paths here. So this path that is highlighted is the training path. We start with our emotion videos and our ResNet, which I'll talk about, and then go through and eventually end up with scores for these videos. Path number 2 is our production deployment path, which we'll talk about when we get there. So to start very small, I have a bash script here that will connect to zenodo.org, which runs or hosts this data set, and loop through the 24 different actors and download all of those videos of them speaking their phrase, unzip those videos, and move it to my output folder. I did it this way just so we have all of the flow for this experiment completely encapsulated in Dataiku. I don't need to do anything outside of the platform. This script will build my data set. If I move on to the next, the output folder for that, I now have, I'm sorry, it's 1,440 videos from each actor having a different speech. So given my videos, what I want to do is extract frames. I can use this using OpenCV's Python library to do some video manipulation. So here I have a Python code recipe. And it's pretty straightforward. Dataiku will tell me a little bit about my inputs and outputs. So my inputs is this emotion video folder. I have a couple functions I define here to help things, but I'll come back to those when we get there. But in general, I load up my emotion video folder and I get all of the files from that folder using this list paths function. Then for each file, I apply these get emotion and get intensity functions, essentially just to decode the file name. So there's a table that says, emotion number 5 is angry, and so on and so forth. I'm just building up a pandas data frame that contains the path and metadata for all of my video. Then for each video, I set a range of frames. So I'm doing this kind of as a percentage of the total video. So I'm pulling out every 5%, I'm pulling out another frame. So I get the very first frame, which is 0%. The second frame is going to be 5% of the way into the video, and the final frame is 100% of the way in. I have this extract frame code, which uses a couple tricks here, as well as our OpenCV plugin. So with Dataiku, all of my folders can be either local file folders, or they can be S3 based or other cloud folders. So this is actually compatible with both. So I can allocate a temporary file on my local machine, and then I use this get download stream Dataiku function to access that file from the folder, no matter if the folder's on the cloud or local. I don't have to worry about that. I just download that file to my temporary file, and then I open it with the OpenCV's video capture object. And from there, I can take my maximum number of frames to get the total number I'm dealing with. I go through, and then for each frame, I set the frame position, and I grab that frame, and I return it back to the calling function. So that goes through here, and I build a data frame containing the path of all my image files now, and I pass that as an output. So if I jump back up to my flow, I can see my output here are the images, which I opened that folder earlier. You can see all the image files, and this image CSV, which just contains, for each image, it contains the frame number, the image path, and the original video path, as well as the classification information here. So from that, I have to do a little bit of manipulation. I want to use this split function to break my images into a training and testing set. And I use a random subset of column values mode here, because I want to make sure I don't mess up here. I group my rows with the same video path. So I'm making sure right here that my videos are either entirely in the test set or entirely in the training set. I'm not mixing frames from one video across both sets, because if I did that, I'd have some information leakage, and my network might be learning about the background or specific features of the video itself instead of the emotions. So at this point, I now have images. I have testing and training images, which are just my data sets containing the metadata of the image itself. And I'm ready to actually build my network here. So as part of the Deep Learning for Images plugin, I get a couple macros I can look at. So one of my macros for this plugin is to download a pre-trained model. So I can download the ResNet model, which is a popular deep learning network trained on ImageNet. So this is going to download the weights and network structure and store it in this ResNet folder. So if I were to look here, this is a TensorFlow weight format containing some information about the structure of the model, some information about the labels that were used in the original training. So this is trained on ImageNet, which has images of terriers, schnauzers, great white sharks, a number of different things. That gives me my starter network. Now I can use this retrain image classification model recipe, and as inputs, I have a data set with image paths, and the label is emotion we're using for training. And I can set up my model parameters here. So I define my image size and the pooling method I use, which you can get more detail from the blog post as far as what all this is. I tell the network that I tell Dataiku rather to retrain all layers of the network. The other option is just the last layer, last couple layers. And I set my parameters of training, One interesting thing I do here that's worth calling out is this data augmentation. I can tell Dataiku to use a Keras image data generator to randomly shift, zoom, and rotate these images in order to generate more data to use for training. And I ran this thing on a GPU instance, which I highly recommend. It definitely made it run much faster. So that gets my network retrained, and now the new weights are stored in this trained ResNet, which now the model labels are updated to show what I'm actually training with. My structure is updated, and I have updated weights. And note this is about 90 megabytes of weight, so it's not an insignificant number. I then have a quick script that grabs my test images and puts them in a separate folder, because this next recipe to score these images takes a folder containing the image files, a folder containing the weights of your network, and essentially just does a classification. So it runs the network over these test images and creates a prediction object, which is stored into a data set right here. So this data set has my image file name, has a JSON object containing my prediction, and then a flag of whether or not there's an error. I'll kind of skip over a lot of these steps here just in the interest of time. But essentially what I'm doing is taking that object and unpacking it so that apparently I'm rerunning this stage. I'm unpacking it to get values for each of these classes. I'm then running through a group in order to get the highest rated vote for each frame. I'm doing some cleanups here, and I end up with my scored video, which just has my video path, the label, which is the majority vote for each frame, and then a flag here with a 1 or a 0, depending on if the most frequent label matches the actual ground truth label. And this is just for my test set of videos. So if I go up here to the most frequently correct flag and hit analyze, then we see an analysis of this column, and I can look at the number of 1 values I have, which is the number of videos that were correctly classified, and see that it's 97.2%. So of the videos, I've only misclassified 8 of them. I can compare this actually back to some of my earlier data sets just to see something interesting. So I have, before I do some of my translation, I have a row for, I've not gone back far enough. So I have here in one of my data sets, I have a row for each individual image with the prediction for that frame, and then a flag on whether that frame itself was correct. So if I look at that column, I can see that I got 90%, 91% of the actual frames of the videos correct. And then when I combine that into the majority vote, I can look and see that I've gone from 90% correct on the frames to 97% correct at the video level. So it's a big increase in accuracy. So that is the flow itself. This is how we train our network. We end up with this trained ResNet folder containing all of the classification knowledge, the machine learning itself. Now let's talk about how I can actually deploy that. So what I've done here is created another path containing videos to score, code that pulls out those frames and drops it in images to score, and a separate classification pipeline that essentially just takes the videos to score and generates labels. I also have gone here into my scenarios for this project. And again, I'm skipping over a lot of the Dataiku specific knowledge. They have great documentation, and you can look at the blog for, well, actually, this part is not in the blog. So we'll do a follow-up post containing the productionization of it. But essentially, I have a scenario which will score all of the videos in that folder. So first step clears out all of this old data. Clears out all the old results. So it's clearing the data sets here, not the files themselves, which is important. My second step builds this scored video data set. So this triggers all of the frame extraction. It triggers all of the network running. It runs that whole pipeline. And then my last step clears the files themselves. So effectively what this means is if I were to drop videos in this video to score folder and run this scenario, I end up with a data set containing the scores of those videos, and then I erase the videos themselves. So what I'm building up towards here is an API to serve this model up to consumers. So I go to this API designer. I've created a new API service, which I won't go through, but I've called it phData Score Video, and it has an endpoint. That endpoint is a custom prediction Python code. So essentially, what Dataiku's API deployer will do for me is it will set up all of the background plumbing required to serve a REST API. It will give me a Python package to call this API. And then when I run the predict method of that API, it will call this class and pass in a data frame containing all of the features that were passed into my REST API. So this is really where a lot of cool stuff happens. And I'll be changing these credentials, but I'll ask you not to use them right now. I notice my API key is kind of exposed here. So I tell this thing to access my Dataiku instance, and when this REST API is called, I pass in a base64 encoded version of the video itself. So for each row in this data frame, the data frame being the videos passed into my API, I upload that video into my folder that I just set up as part of this whole scenario. And then I use the Dataiku API to grab that scenario and run it. And I wait for the results. I then take that result data set and I go through and grab all of those results and I pass it back as my classification decisions and probabilities. So this is the back end of this API. I'll skip over the path of actually deploying it. It's pretty straightforward. You just push it to your deployment nodes and it handles the rest. And I'll jump over here to a Jupyter notebook that I've created in Dataiku to test this scoring API. So what this notebook does is I've got some of the same code here to decode the file names and all that, but I've taken a sample of 5 different videos. And for each of those videos, I download it from my network folder just to keep me from having to track these files manually. I just download it from the place I've already stored it. And I base64 encode that video, and I'm creating this records array. So what I can do then is I have this Dataiku API package that they provide. I create a Dataiku API client, which I blanked out my credentials here, but not any other place, which is fine. And so I call client.predictRecords, and I'll go ahead and run this. And what you'll see when I run this is still the data API service. So you'll see some status windows pop up as internal bits of data API kick in. But when I call predict records, you notice the scenario has now started. We've now started the job to build these scoring videos. So in the background, Dataiku has received these uploaded videos. It is extracting the frames. It is running the frames to the deep learning network. And then it will do the majority vote classification, or I guess actually for this, it uses the highest average score, which is approximately the same, and then passes those prediction results back down via that REST API. And you see I've got the time tracker here. I think it takes about 1.5 minutes. I've grabbed 5 videos. If I jump back over to my phData flow here, or I'm sorry, my project flow, I can see this is now dotted with a play and calculation symbols. It's now running through. If I look at my video to score folder, I've uploaded these 5 videos here, and I can kind of grab one of these data sets in progress and see that it's still being built. So I'm still running through this scoring. Down here, I now see that it just completed this job and finished the scenario. So if I look in my data set, for each of these 5 videos, I have a prediction score. If I jump back over to my notebook, I see that my method completed, it ran for 1 minute and 23 seconds and stored my data in this predictions object. If I just dump out the predictions object itself, there's a lot of information in here about the service and results and all that. I can pull out just the result labels. So on the left-hand side, you have the ground truth. On the right-hand side, you have the predicted label. All of these videos were classified correctly. I can also pull out my probability scores if I wanted to see each individual class and score, and see that for the first video, angry was 0.999, and that's the correct class. The second video, happy, got where is happy? 0.86, so it's not as confident, but it's still the majority. And then for the last video, I was trying to find one that was a close call, but these all are pretty one-sided decisions. But that's how I can score these videos. So in a production setting, Dataiku's API deployer will deploy this API to as many nodes as I like. Those nodes will upload the video to my central Dataiku server, which can run this classification and pass the results back down to the client. So that is our end-to-end process. As I said, there's a link in the chat, hopefully, for the blog post, which will cover everything except for the deployment. There is a link to the GitHub that will have all of the code, including the deployment code. And that's that. So I'll throw this flow back up here on the screen and pause for some questions. I'm told there's a bit of a lag, so I might pause for a bit longer than you'd expect, but hopefully there'll be some questions or discussion and we can go further. I do love these webinar style formats. While I wait to see if questions filter in, we all can just examine the room itself I'm in, or otherwise make one-sided idle conversation like this right here. Well, looks like there may be no questions, so I'm glad that everyone perfectly absorbed all the information, and hopefully it was helpful. I think I covered just about everything in some amount of depth. I didn't skip over too much. For what it's worth, the training process for this network, we ran on an AWS GPU machine. There is a Dataiku AWS image, which makes that reasonably easy to set up. And it trained for, I think, 12 hours or so, just because we had plenty of time for training. I could have trained it for an hour or so and got reasonable results, but we saw with more training we had higher accuracy. So even with very little training, we were seeing about 80% accuracy. We did have a question come in saying, is it possible to import LTO files? That is an excellent question. I'm not familiar with what an LTO file is. I quite possibly should be, but I'm not sure if that is a typo or a particular file. Oh, is it possible just to import into files? So data sitting into the file systems. Yeah, it's very possible if the question is importing video data, then this folder right here that we're using to store the video data is a local file system folder. So if I look at the settings here, I can actually look at the path of this folder and I can SSH into the system and look at the folder files themselves. The actual output data sets are similarly stored on the file system. You can have this stored in the cloud if you like, but by default it's just a CSV sitting out on our Dataiku server. So hopefully that addresses that question. I'm not quite sure actually what the question was as far as what we're trying to import or export. But in general, these can be files on the system. They can be files in an S3 bucket. So yeah, the question was importing the video data. So yeah, we can certainly do that. The first version of this experiment required me to manually upload these videos to the server and then just point my folder in the correct place. So it was only like, I think, version 3 where I upgraded to this shell recipe that did the downloading for me. Gotcha. Yeah. So the video data can be stored into arbitrary file systems. So yeah, it right now this version stores it as a folder on the local machine. A previous version of this experiment used an S3 folder for that, just to pretty much prove that we could. And just for the sake of bandwidth and being able to run these things quickly, we later moved it to the local file system. But yeah, this could be a cloud folder containing an arbitrary amount of data. And that's one thing, that's one reason when we look at this code recipe here, I use Dataiku's API to get download streams instead of just using like raw file copy operations. That gives me that abstraction layer. So those videos could be living on the cloud or in different machines entirely, and it doesn't really matter for the code flow for the operations project. Well, it looks like there are no more questions, so hopefully this was very worthwhile for everyone. I'd encourage you to look at the Dataiku deep learning blog posts on phData's site for some more information. The Dataiku site has the plugin information and some good documentation there about everything you can do. Feel free to contact us and reach out for more information about any of that. And I know Dataiku is pretty easy to work with as well, so I'm sure they're happy to have those discussions with you also. Thank you for attending, and we'll go ahead and close out the session, and everyone have a nice day.